In this video, we will learn about data frames in R programming language. Data frames in R are table-like structures that are used to store data. Each column contains values of each variable. Each row contains a set of value related to each column. The column names are non-empty. Row name should be unique. The syntax to create a data frame is: first we write the variable name followed by the left operator. After that we write data.frame, and inside the brackets we write the data for which we want to make data frames. Now let us see a practical implementation of data frames in R programming language.
In the first line, we have created a variable with name employee.data followed by the function data.frame. So here we are trying to create a data frame using this function. Inside this, we will have values employee ID, employee name and salary. The employee ID will have numbers from 1 to 4. The employee names will be defined using a vector, like this is a vector and these will be the names of 4 people. After that, this is the salary element and this will also have 4 values. Strings as vector is a parameter passed in the data.frame function and the value of this is false. Now we'll try to create this data frame. After this, we'll print the values in this data frame. So now this is the data frame. The employee ID is from 1 to 4. The employee name are as given in this vector and the salary is also same as given in this vector. After this, we'll try to get the structure of this data frame by using the str function. This is the structure of this data frame. It has 4 observations of 3 variables. The 3 variables are employee ID, employee name and salary. As given here, employee ID, it has 4 observations. Similarly, employee name is of type character and it has 4 values again, and the salary is of type number and it also has 4 values. Now we'll try to print the summary of this data frame. The summary function will give the summary of this data frame. Like employee ID has minimum ID as 1. The first quartile is 1.75. The median of employee ID is 2.50. The mean of employee ID is 2.50. The third quartile is 3.25 and the maximum value of employee ID is 4. Similarly, employee name has a length 4. The class of employee name is character. The mode is character. If employee name was of type integer, again we would have seen this kind of values, but as employee names are of type character, so it is not giving mean, median, etc. for this. Finally, the salary variable, the minimum salary is 44440, as we can see here. This is the minimum salary. After that, the first quartile is 49736, and similar to the employee ID, all the values are given here and the maximum value of salary is 63003. After that, now we'll try to add one more column to this data frame. Now we'll run this line. This has added one more column to this data frame with the name department, and the values of this are network, software, mobile and web. Now we'll again try to print the employee data. So now when we try to print the employee data, it has one more column, that is department, and the values are assigned as network, software, mobile and web. This is all we will do with data frames. Thank you.
In this video, we will learn about packages in R language. Packages in R are a collection of functions and sample data. By default, when we install R in our system, some packages are installed with that. There are some functions in R that are helpful when we are dealing with packages. First is a library function. This gives a list of all the packages that are already installed in our system. Second is install.packages. To install a new package in our system, we use this function. Inside the brackets, we write the name of that package. Third function is used to load a package to a library. The syntax of using this function is, first we write the library keyword followed by the starting bracket. Inside this we write the package name followed by a comma and followed by the directory where the package is located. Now let us see a practical implementation of all these functions.
In the first line, we are trying to get the library locations where our packages are stored on our local machine. For this, we use the .lib paths function. When you try to run this, this will give us the path where all the libraries are stored. In my device, all the libraries are stored in library/frameworks/R frameworks version 3.4 resources, and inside the library, all the packages are stored. After that, we'll try to get the list of all the packages that are installed. We'll try to run this, and this will give us the list of packages in our library. So these are all the packages that I have installed in my device. After that, we'll try to see all the packages that are currently loaded in our environment. For this, we'll use the search function, and this will give us the value of all the packages that are currently loaded in our environment. After that, we'll try to install a package called XML by the statement install.packages and the name of the package. When we run this, it will try to install this. So currently it cannot open the URL because my device is not connected to the internet. So when you try to run this and you are connected to the internet, it will go and download XML package for you. After that, you can install the package. After that, you can load the package XML by the following statement like library XML. So because my device was not connected to the internet, it could not be downloaded, but I have downloaded the package earlier also, so it can import the package in my environment. This is all we will do with packages. Thank you.
In this video, we will learn about data reshaping in R language. By data reshaping, we mean changing how data is represented in rows and columns. In R, most of the data processing is done on data frames. R has many functions that deal with data reshaping by splitting, merging, or interchanging the rows and columns. Some of the data reshaping functions are cbind, rbind, merge, and many others are there. Now we'll practically see some of these functions.
In the first line, we are creating a vector named city with the following values. After that, we are creating another vector with the name zip code and the following values. Now we will combine the above two vectors into a single data frame using cbind function. The name of this data frame will be old addresses and the values will be city and zip code. Now we'll try to execute these lines. After this, we'll try to print the header of this data frame. For this, we'll run this line, and these are the values inside this data frame. After this, we'll create another data frame with similar columns but different values. The name of this data frame will be new address, and this will be created using data frame function, and the values inside this will be city equals to a vector of cities and zip code equals to a vector of zip code. We'll execute these lines. After this, we'll print the new addresses, and these are the values inside the new addresses. Now we'll combine the rows from both the data frames using rbind function, and this will be stored inside a new data frame that is total addresses. When we run this line, and after this, we'll print the total addresses data frame, and this will have the values from previous and old data frame. As we can see, earlier first data frame had 4 values and the second data frame had 2 values, and now this new data frame is a combination of both the first and second data frames. This is all we will do with data reshaping. Thank you.
In this video, we will learn about opening files in R. R has a support for handling files outside the R environment. That is, we can open and write and read files outside the R environment also. R can read and write various file formats like CSV, XML, JSON, etc. To read CSV file, we write read.csv and inside the brackets we write the name of that file. To write a CSV file, we use write.csv and inside the bracket we write the file name and the value. Similarly, we have packages and libraries to read and write other file formats also. Now we'll practically see some of these functions.
To open a file in R, you must have the file in the same directory as you are running currently. Now we will try to open a file named toyota.csv, that is, this file is of type CSV. CSV basically means a comma separated value file. We'll open this file using the read.csv function and we'll store these values inside data1. As you can see in the files folder, we have toyota.csv file. So we will not have any problem in opening this. After this, we'll print the values inside the data1. First, we'll execute this line. Then we'll print the values inside this data1. So these are the values inside this data1. These are not all the values. Some values have been skipped. That is, the maximum values it can print is 100. So it has omitted the next 1336 values. Now we'll try to see whether this is a data frame or not. This is a data frame as we are using this function print is data frame and we have applied this on data1, that is this value. So this will return true or false. If it is a data frame, it will return true, otherwise it will return false. After that, we'll try to see the number of columns in data1. For this, we'll use the function ncol and the data1 data frame. So the number of columns are 10, as we can see from here also. The number of columns must be 10. First, second, third, fourth, fifth, sixth, seventh, 8th, 9th and 10th. So it has 10 columns and the number of rows can be seen using nrow function. So it has 1436 rows. After this, we'll try to see the maximum value of kilometer variable. For this, we'll use max function applied on the variable. So the maximum value inside this is 2,43,000. Now we will try to get all the data related to the maximum value of kilometer. That is, now we will fetch the complete row inside which the kilometer has maximum value. To do this, we'll use a subset function. The data will be from data1 and the condition is where kilometer is equal to maximum of kilometer. This subset will be stored inside this frame. To run this, we'll get the maximum details and now we'll print the maximum details. So where kilometer is 2,43,000, all the values are like this. After that, we'll write these values, the maximum detail value, in a CSV file using the write.csv method. To use this method, first we need to write write.csv and inside this we'll write the value and then the file name that we want our file to have. So we'll create a file output.csv. Now when we execute this statement, you will see that a new file appears in this. Now we'll run this line and now we will have a file known as output.csv. This is the file output.csv created at the same time as the current time. So after this, we'll try to print the value of our file output.csv using these two lines. And as you can see, the values of the maximum details and the file are same. So we can say that we have written successfully using the write.csv file. This is all we will do with file handling in R. Thank you.
In this video, we will learn about web data using R. By web data, we mean data from the internet. R can make use of data provided on internet for public usage. Using R, we can extract the required data from those websites. We need some packages like rcurl, XML, stringr, etc. for handling web data and for getting the data from those websites. We'll use functions to get the URL of those files, and then we'll save those files on our local machine to perform some operations on them. Now we'll practically see how we can make use of web data in R.
Now we'll try to fetch some data from the given URL using rcurl library. As I have already installed this library, so I will not execute the first line, but you must execute this to install the rcurl package. After this, you have to import the library in your current working environment using the library function followed by the name of library that you want to import. After that, I will be creating a variable called sample in which I'll store the value that I receive from this URL using the read.table function. You can choose any URL from where you want to retrieve the value. I have already executed this step also, so what I'll do is I will just select these two lines and I'll run on my device, but you need to run all the lines one by one. When I run this might cause an error on my device because my device is not connected to the internet. This will show error in this line. After this, because I have already executed this before also, so the value inside the sample will be, this is how you can retrieve values from a URL. This is all we will do with dealing with web data in R. Thank you.
In this video, we will learn about database using R. Using R, we can connect to relational databases on our device and then fetch data from there. Steps to fetch data from a database are: first, we'll need to create a connection with the database. Then, we'll need to send a query to the tables, and after that, we'll need to fetch the results. Now, we'll practically see how we can perform all these steps in R language and fetch data to perform some operation on that.
To fetch some data from our local database using MySQL, we can fetch data from our local database using our MySQL library. To do this, first you will need to install the library, but as I have already installed this, so I'm directly calling this in our working environment. After this, you need to create a connection with the database. For this, you will need to write a query that will be SQL connection is the variable name, and this is the function that you need to connect to a database. This is db connect. After that, the name of the database followed by database name followed by host name. After that, you will write user's name, and after that you need to write the password of your database. But in this, to introduce a new concept, I have not written the password directly, but I am asking the user to enter a password. You can do this by using .rs.askForPassword, and this is the line that will appear when it will ask for password. We will see this in a short while, but before that, let me tell you what I have done here. First of all, we have created a function to create to a database, because in our application we might need to use this again and again. That is why we will use a simple function. We have given this function a name connectDB. After that, we have written the function definition. So we write a function as we have seen previously also by using function keyword followed by these are the parameters that we want to pass in our function. First is the database name, second is the host name, and third is the username, as we have used them here also. After that, we have made an empty statement SQL connection, that is null. After that, we are trying to get the result of SQL connection in this result variable using try catch function. Here we are introducing again a new concept of try catch. Try catch is used to prevent any kind of errors in your programs. The syntax of using try catch is, inside the try catch keyword we write the code which may cause an error. Like if you want to try to connect to a database and maybe the database does not exist or the password or username is wrong, so this might cause an error that the database does not exist or the username is incorrect. So we write this code inside the try catch block. So this will not stop our program, but this will give us a warning. When we receive a warning, then it comes inside this warning function. After that, if we receive an error, then it comes inside the error function. Whenever we receive a warning, we use suppress warning to suppress that warning so that the warning does not stop our program. and whenever a error occurs, we'll print the error. Finally block is used if everything of this is done, then finally this block will be executed in any case. After this function connectDB will return the SQL connection. SQL connection is the connection that we have created in this line. Inside the function we are passing database name that will be used inside this query, as we have discussed earlier also, that DB connect will connect to the database. For this we need the database name, the host name, username and password. So this connectDB function will return a SQL connection. After that we need to fetch the result using some queries. We'll use this function in another file. In this file, first we have imported the library r/MySQL. After that we have imported our connection.r file that we have created here, inside which we have created the connection. So now we can use each element of this file connection.r inside our new file. Now we'll try to create a connection to the database. First we have written con, that is the name of variable, any name can be there. After that we are calling the function connectDB that we have previously defined in our connection.r file here. So we have made this function and now we are calling this function in our new file. For that we had to pass three parameters. First is the database name, second is the host name and third is the username. Here we have given the database name and we are running this on local device, so host name is most probably localhost most of the time, and the root is the name of my database. So now when we try to run this line, then it will ask for password, and the text written here is enter password, as we have written previously in .rs.askPassword. When I enter the password, it will give me the access. It is giving print connected. So this has connected to my database. Now this is a warning you can ignore. After that we have connected to my database. After that now we'll create a query. Query means we are sending a query to the database to give us some value. So now this is created using db send query function. Inside the send query we write the connection that we have created here. So this is the connection. We pass the connection followed by the query. A query is given in SQL format inside a string. So we pass this string along with the connection to db send query function, and the value that it will give us back will be stored inside the query variable that we have created. Now we will see how we can fetch the data from database. Till now we have seen how we can create a connection, how we can create a query, and after that we will see how to fetch the data. To fetch the data, we simply need to write a function fetch, inside which we'll write the query that we have created. After that we'll write n equals to -1. This basically means it will fetch all the data that the query function will return, and all the data that the fetch function will give will be stored inside this data variable. After this we'll run this line also. First we'll run this query. Now we'll run this line to fetch the data. So after this, for a security reason, you must disconnect from the database. This is a good habit not only in R, in any programming language. This is a good habit, and the previous steps that we have done till now for fetching data from the database are same in most of the programming language. First you need to create a connection to the database, then you need to send a query to the database. After that you need to fetch the data, and after that you must disconnect from the database. Now we'll disconnect from the database. So it has disconnected from the database, and after that it is giving a warning that open result set have been closed. Now we'll create a new data set called car data, and we will remove all the values that are not available. NA stands for not available inside our data that has been fetched from the database. We are removing all the not available values using NA, that is not available dot omit. Omit means to ignore those values from this data set. and we are storing this inside the car data. Now we will just print car data and we'll see all the values inside the data that has been fetched from the database. So these are all the values that were inside our database, and you can see all the values are there because we have used the function na.omit. So all the values that were not available will be removed. Now this is all we will do with connecting to the database and fetching data from the database. Thank you.